the main concept behind here, it is the multiplication of a vector by a scalar. For that, we need to understand the components of a vector. Okay, so let's first see what is a multiplication of a scalar by a vector. Suppose A is a vector, okay, and lambda is a scalar, that is a real number or a quantity. Then the product of the lambda with the vector A is called product of the vector A and the scalar lambda. So this is called scalar multiplication. So lambda A will be always collinear with the given vector A. The product scale vector multiplied with the scalar will always be collinear with the initial vector. Okay, so direction of lambda A is same as the or opposite according to the value of lambda. If the lambda is positive, it will be of the same direction. If the lambda is negative, it will be of the opposite direction. Okay, when lambda is 1, lambda A will be equal to A, and if the lambda is equal to -1, then the product will become minus A. Okay, is a vector of the same magnitude but of the opposite direction of given vector A, right? So thus it's called additive inverse of a or negative of a vector. That means what is additive inverse? That is something we add to get zero vector. Okay, so what is the additive inverse of A? Minus A. And how do you obtain additive inverse of a given vector? By multiplying -1. That's a scalar. Okay, if lambda A represent a unit vector in the direction of A, that can be expressed as unit vector. So what is unit vector? Remember how to find a unit vector of a given vector is, it is usually represented by a cap symbol, and you take the vector and divide by its magnitude, and only it will be giving you the direction. Such a vector is called unit vector. Okay, it is very important to understand the next part of this class, which is components of a vector. Okay, let's see what is it. So they are taking a point here, okay, on the three-dimensional axis. Again, I'm trying to redraw this figure. This is z-axis. This is y-axis. According to the figure, I'm writing the same diagram. And this is x-axis. Okay. Yes. Now let us take the points on these axes. Let it be B. Let this be A. Let this be C. And the coordinate of B be 0, 1, 0. And coordinate of A be 1, 0, 0. Coordinate of C be 0, 0, 1. Do you understand? The coordinates are unit distance from the origin. Okay. In such case, the vector along the z-axis, vector along the y-axis, vector along the x-axis, with the endpoints OA, OB, and OC having the magnitude of 1, such a vectors are called unit vectors. Magnitude of this is 1. Magnitude of B is also 1. Magnitude of the vector OC is also 1. They are called unit vectors along the given three axes. They are usually represented by the letter I cap, and this is J cap, and this is K cap. So what are IJK? IJK are the unit vectors along the axis x1, xy, as well as z. Okay. Now let us consider the position vector OP at a point P. Now if you are comparing this with the position vectors, what will happen is, if you take a position vector, why are we learning this? To understand how to break down a given vector into unit vectors. Okay, so that's very important for us. If you have a position vectors in a space and it is represented by x, y, z, then its direction cosine direction ratios will be ABC. Let's assume. So a perpendicular line from here along y-axis. Let this be x-axis. Let this be y-axis, and let this be z-axis. Now the perpendicular projection of this along the y-axis and x-axis and z-axis be a. Let this be distance a. Let this distance be b. Let this distance be c. Okay. Now this vector OP can be represented by the dimension x, that is a into I cap plus b into j cap and c into k cap. Whereas I, j, k are the unit vectors along the x-axis, y-axis and z-axis, and a, b, c are the direction, length along this, are the projection of this projection vector along the x-axis, y-axis and z-axis. So now let us consider the position vector OP at a point P represented by x, y, z, and P1 be a point at the foot of the perpendicular from the point P on XOY plane, like this. XOY plane. This is P1. Let this be P2 and then P3. So that's what they are showing here. So let's see how they have explained this part. Yeah, so there's a direct diagram here already. So here, see here, P1 is along XOY plane. And yeah, so then what is P1P? Here P1, here P. P1P. The vector P1P is represented by OR. Okay, so that is, here it is. ZK, and yeah, all the explanation what I gave is represented in this diagram. You can apply it, I can understand that this OP1 is actually OQ1 by using the triangular law of addition, and QP1. So which will give you XI plus YJ. Okay. Similarly, if you want the complete vector OP, which has to be added by QP1 and PP1, which is XI, YIJ, and ZK. This representation of vector is known as a component form of a vector along XYZ axis, and this X, I, Y, J, and ZK are called vector components along the given directions. Okay, we can even replace this X, Y, Z by letter A, B, C as I mentioned. Okay, so let's see how are we going to use this in our classes, in our questions. Okay, further moving forward, the length of the vector OP is given by, that is a magnitude. Length is nothing but what? Magnitude of the given vector is given by, like this, we can mention like this, which is nothing but square root of x square plus y square plus z square. Okay, so in general, if there are two vectors for us, vector A and vector B, how can we add them along the components? So vector AB, A1 I cap, A2 j cap, and A3 k cap, and B be represented by B1 I cap, B2 j cap, and B3 k cap. Then how do we add these vectors is vector A plus vector B is I cap is common, so we are going to add only that length A1 plus A2, the corresponding A1 plus B1, yes, and A2 plus B2 with a j cap, and A3 plus B3 with a k cap. So that is addition. If you want subtraction, you can subtract the corresponding coefficients of the unit vectors I cap, j cap, and k cap. So that is how we use these components while adding the two vectors. Okay. Pictorially, we know we can use a triangular law or parallelogram law, but quantitatively, if we want to observe and find the sum of the vectors in terms of its components, we have to add the corresponding coefficients of unit vector components. Okay. Yes, I hope this is clear so far. And similarly, if you are multiplying a vector with a scalar, if a vector A is multiplied by a scalar, if the vector is in the form of A1I plus A2J and A3K, if you're multiplying by lambda, it will become lambda is multiplied by each of the vector component. Okay. So like this, individually we can distribute this. So scalar multiplication is distributive in nature to all the components. Okay. Similarly, if you are saying two vectors A is equal to B, It means that A1 is equal to B1, B2 is equal to A2, and C2 is equal to B3 is equal to A3. What are these? A1, B1, A2, B2, A3, B3 are corresponding coefficients of their unit vectors I, J, and K. Okay. If two vectors are equal, even if the corresponding coefficient should be equal to each other. Okay. Yes, all these we're going to use this in our calculations. So be aware of these things. Okay. Let's see some solved examples to understand them better. Yes. Let's look at this. So there is a vector A which is represented by I and 3j, and B is represented by 3I plus 1j. Okay, so is the magnitude of vector A is equal to magnitude of vector B. Obviously, A is not equal to B. You can see that, right? Because the corresponding coefficients are not equal. But is the magnitude is equal? Let's see. So what is the magnitude of vector A? Square root of what is the coefficient of I? 1 square. Coefficient of j? 3 square. Coefficient of k is 0 square. So when we do this, we get 9 plus 1, 10 root 10. What is the magnitude of b? B is root of 3 square plus 1 square plus 0 square, which is also root 10. So that means the magnitude of vector A is equal to magnitude of vector B. Okay, is this equal? Yes. First question, yes. What is the second question? Are the vectors A is equal to vector B? No, they are not equal because the vector components are not equal. So no, A1 is equal to 1, whereas A2 is equal to 3. Correct, no? So sorry, B1 is equal to 3 and A2 is equal to 3, whereas B2 is equal to 1. Because the vector components are not equal, these vectors are not equal, but their magnitudes are equal. Now find the unit vector in the direction of given vector M. So how to do this unit vector? So how to find a unit vector is, we know every vector can be represented by a unit vector, okay, A cap into its magnitude. That means if you want a unit vector, you just have to divide the given vector by its magnitude. Okay. So how to get the unit vector of M here? Vector M is represented by what? 3I plus 3j cap plus 5k cap. Now its unit vector M cap is given by the vector given vector divided by its magnitude. So what is the magnitude of the given vector? The magnitude of the given vector is square root of its direction ratios. Direction ratios are 3 square plus, yes, 3 square plus 5 square, which is 18 plus 25. 18 plus 25 is 43. And then what is the required vector is the given vector 3i plus 3j, that is cap, plus 5k, entire thing divided by what? Root 43. So this is our unit vector. Okay, so it may not make much sense for you until we use the application of this, but for us time being, we are going to understand the unit vector. We are going to find them like this. We can individually divide and keep it like this as well. Okay, vector joining 2 points. Vector joining 2 points. What will happen to that vector? So there is a point P1 which is represented by the coordinates x1, y1, z1, and there's another point P2 which is represented by x2, y2, z2. So now the vector joining the 2 points is represented by P1, P2. How to get that here? See here. So I can say OP1 is a vector. Okay. OP1 is a vector which is represented by x1 j plus y1 x1i plus y1j plus z1k, and OP2 is another vector which is represented by x2i y2j plus z2k. Then what is this joining the vectors p1 and p2? This is actually sum of OP1 and OP2. Can you see that? No, this OP2 is actually sum of OP1 and P1, P2. So that means I can say OP1 vector plus P1, P2 vector is equal to OP2. So in that case, what is P1, P2? That is a vector joining the 2 points. It is sum of OP2 minus OP1. That is subtraction. So vector joining the 2 points P1, P2 is given by this, which is x2 I. I can take I common, right? Yes, to reduce. I'm just skipping one step. X2 minus x1 I plus y1 minus y2. It has to be in the reverse direction. So I can say directly P1, P2 is actually x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So this is the vector and its magnitude is given by x2 minus x1 whole square plus y2 minus y1 whole square. So here the magnitude, it doesn't matter what order we are taking, but in representing the direction, it has to be like this. So quick understanding of this, if you have a point P1 and P2 in such a way that this is P1, P2, and OP1 is a position vector of P1 and OP2 is a position vector of P2. So if I'm joining from P1 to P2, so this P1 to P2 will be nothing but sum of what? OP1 plus OP2. So if you want, yeah, small correction. What is the correction? Tell me. The direction has to be correct now while adding the two vectors. That is OP1 plus P1 P2 vector is equal to OP2. So if you want only P1 P2, we have to subtract OP1 from OP2. That's what it is. Okay, OP2 minus OP1. Just remember this, it will be helpful for us while solving the questions again. Let's look at the first question. What does it say? The scalar product of the two vectors assertion. It's an assertion reasoning question. It says scalar product of the two given vectors A is given by 6i minus 7j plus 5k and vector B is given by 6i minus 7k. So what is the product? It's saying 8. So let's see. Vector A, vector B is equal to what? 6 into 6 plus minus 7 into minus 7, right? And then what else we have? Plus 5 into 0. What we get is 36 minus 40. What is it? 9. So are we getting the same answer? Let's see. Is the order correct? A small correction here. Let me rewrite this. The small correction is 6 should multiplied by 6. Yes. 6 into 6 plus 7 into minus 7 into 0. Right, and then 5 into minus 7. What do we get? 36. Am I right? 6 into 6, 36 minus 35 is equal to 1. So, but they are saying 8. Let's see the answer first. So, assertion is obviously wrong. As assertion is wrong, the answer should be D. Let's see what is the second part. It's saying if there are two vectors A, B, they are components of A1, A2, A3 and B1, B2, B3 respectively. Then the scalar product is given by multiplying the respective components. Is this correct? Reasoning is correct, whereas assertion is false. Because if you apply the same reason, this is coming as 1, not 8. So is the reasoning right? Yes, it is right. So what they have done is correct here and they have given clearly yes. So that means the reason is right and it's a right explanation for the given assertion, whereas the assertion part is wrong. So which is the answer? Option D, A is false and R is true. Is that clear? Yes. Let's go for the next question. What is the next question? The product 2a plus 3b. Okay, let's see. 2a plus 3b dot 4a minus 5b is a dot a square plus 2a dot b minus 15b square. So how can we solve this is, so we know there's only a dot product. Dot product always ends up with a scalar and we have to multiply. So is it right? Let's say first question. What is the reason says? The reason says uh, reason is giving something else, same values, right? 2a, 3b and 4a, 5b. So let's look at the product. Let's solve that and see. When you multiply 2a and 3a, 2a and 4a, we get 8 into this whole square plus 3 into 4, 12 times this AB, and then minus 10 times A dot B, okay, then minus 15 times B modulus whole square. So when you multiply further, 8 into E modulus, I mean magnitude of A square plus 2 times A dot B minus 15 times b square. So the reasoning is correct, whereas it is not equal to given assertion. That means what is it? Assertion is false again, and the reason is right explanation of the given assertion. That means what is the answer again? Answer should be option. What is it? D. So is that clear? Yes. Let's go for the next question. The scalar product of the vectors. What is scalar product of the vectors? A into b. So what I should get is 2 into 6, right? 2 into 6 plus 5 into minus 7 plus 0 into 0. So what is it? 12 minus 35, which is actually minus 23. What they are given is correct. That means assertion is true. As the assertion is true, I can rule out option. What are the options I can rule out? Tell me. Option D can be ruled out. Okay, option D, only option D can be ruled out. So what is the second one reason? Two vectors A and B with A1, A2, A3, A2 representing a vector A and components B1, B2 representing component B. Then the scalar product is A1, B1 plus A2, B2. Correct. That means both the assertion and reasoning are right. And as reasoning is the right explanation for the given assertion. That means the answer is option B for this question. Yes. Yes, quickly, let's go to the next question. Question number 4. So the angle between the vectors A and B with the magnitude √3 and √2 is represented respectively. Okay, magnitude of A is 3 and the magnitude of B is √2. And A dot B is equal to 3 √2. The angle is cos inverse of 3 by √2, it says. So we know A dot B is actually what? Magnitude of A into magnitude of B into cos theta, right? Into cos theta. So using that logic, they're given A dot B is 3 √2. What is the magnitude of A? Magnitude of A is √3. Magnitude of B is √2 into cos theta. So when we solve this, what we get is this cancels. Cos theta is equal to √3. Theta is equal to, what do we get? So 3 by √3, right? It's √3 by 3, which will be 1 by √3. So theta is actually cos inverse of 1 by √3. But what it said here, it is saying 3 by √2. That means assertion is false. As assertion is false, blindly we can say option D, but we check the reasoning also. Reasoning is true. That means A is false, R is true. That's the answer for us, which is option D. Is this clear?